Alright, hi guys, welcome to the first little bit of remote learning that we have to do. I'm going to start this video talking you through what my expectations of you are again, and then after that we're going to look at the next bit of the topic, which is linear inequalities or inequations. Okay, so in your email you would have got a table that's like this. At the moment it's a little bit, yours is a little bit of a work in progress because I'm kind of filling it in as I go. But you'll see here you should be looking at YouTube video 1, and this is what you need to watch. After that you need to do the attached worksheet that's here. And then I'd like you to go back after you've done that, watch the second video, complete the next worksheet, and then your prep is also attached, and that's to be submitted on Firefly, and I'll just put in there by Friday. Okay. With submitting the prep, probably best if you have a printer, if you can print it, write on it, scan it back to me, and then I can mark it and send it back to you and send the feedback back. Or the other thing you can do is you can write out the questions on paper. Make sure you're being nice and neat, Mallow and Lewis, and just so I can read it. And then what you can do is you can take a photo of it on your phone or use one of the scanning apps on your phone, and then likewise upload it to Firefly, and I'll get it in some way, shape or form. Okay, hopefully that's clear. If you do have any questions, please let me know as soon as possible and we'll sort something out, okay? But you'll get one of these from me every week that we are doing remote learning for. Okay, so on to today. We have done a lot of looking at equations. We haven't done a lot of looking at inequations. So some of the equations that we might have looked at so far are things like, say, 2x equals 4. Okay, so then we know that if we divide that by 2, cancel that out, then x is equal to 2, and that's an equation because you have an equal sign. You know that x is equal to 2, and therefore that is true. An inequation it's a bit of a clunky definition because it's an equation that makes a non-equal comparison between two values. So for example, if we said that 2x is greater than 4, that means that x would have to be greater, again divide by 2, cancel that out, same steps as solving an equation for the most part. There is a bit of a trick later on. So 4 divided by 2 gives you 2, so that means that x is greater than 2. And we should be able to look at this and think about whether it's true or not, because if we know that 2 times x is equal to 4, if that value was 3, which is bigger than 2, then that would mean that that would be 2 times 3, which is 6. That's bigger than 4, so that's true. But if it was 1, it would be 2 times 1, which is not bigger than 4, and that means that is not true. Okay, so again, you're still making a comparison between two values. You're still comparing x and a value, but it's just they're just not an equal comparison. Okay, so the main types of inequalities, and it'd be good if you could write that definition in your book, by the way. You've got the heading and the date up there. The main types of inequalities, we have greater than, okay, less than, greater than and equal to, and less than and equal to. Okay, so there's our 4 inequalities. Now, the first thing I want you to do is just to focus on representing, when you're given an inequality, to represent that on a number line. So, for example, if we go back and we look at x is greater than 2, okay, if I draw out a number line, I'm going to start at 0. So I'm just going up in ones, and I'll go up to 10. Okay, so if we know that x is greater than 2, if we represent this on a number line, if we start at 2 and we go upwards, we're showing all the values that x could be that are greater than 2, okay, and that keeps going. Now I've used an open circle here because x is only greater than 2, it's not greater than and equal to 2. So you use that open circle to show that it's not equal to that value, but it could be equal to all the ones above that. If we're, for example, looking at x as less than or equal to 4, okay, again, I'm going to start at 0, 1, 2. Ooh, what have I done there? 1, 2, 3, 4, 5, 6, 7, 8. Might just draw that going back in the other direction as well. If I'm showing x is less than or equal to 4, starting at 4. Now, because that is equal to, I'm using a closed-in circle, and we're saying x is less than or equal to that, so you're showing all the numbers in the opposite direction. And again, closed circle means that it's also equal to, so it's got that line underneath. What about if we had two values it was between? So what if we said x is going to be greater than or equal to 5, but less than 7? So again, I'm just going to draw up my number line. Start at 0 still, so 0. Hope I fit in 10 in here. It's always a bit of a gamble. 5, 6, 7, 8. Oh, it's not very evenly spaced, but there you go. Now, x is greater than or equal to 5. So again, I'm going to put a closed dot at 5, but it's a less than 7. So I'm going to put an open dot at 7, and now I'm going to join up those two values. Now, you might think that this is kind of stupid because the only things that x could be would be 5 or 6. That's not the case, because you have to remember there's all of those decimal values between 5 and 6 and 7. So x could be, 6.995. It could be 6.13. There's, an infinite number of values just between those. So even though we only show the whole numbers, it could be millions and millions of possible combinations in there. Okay, so now what I want you to do is go on, get that attached worksheet. It's called Number Line Linear Equations or something along that line. Open it up, have a go at it. You don't need to send me this one, but I do really want you to do it. It should only take 5 minutes, and then come back and watch the second video. Okay, all right, thanks, bye.